Welcome to my channel. In this video we will talk about UC3843A. The UC3842 of 3843A provide the necessary functions to implement offline or DC to DC fixed frequency current mode, controlled switching circuits with minimal external components, low startup current typical 0.1 to milliampere, automatic feed-forward compensation, pulse-by-pulse current limiting, under-voltage lockout with hysteresis, double pulse suppression, high current totem pole output to drive MOSFET directly, internally trimmed band gap reference, 500 kHz operation. Let's move on to the block diagram and try to understand it. I hope this video will be very useful for you. Be sure to subscribe to my channel and watch the video till the end. Let's try to understand from the block diagram which operators are used in it. VC voltage will enter at pin number 7. Pin number 5 is the ground pin. Negative volts will enter. The Zener diode is set to 34 volts. You can give a maximum of 34 volts. If you give more than that, it may short and the IC will stop working. If you give it up to 30 volts here, it will be better for it. If pin number 5 and 7 are shorted, then this Zener will be shorted. If you suddenly apply more voltage here, this Zener will move out of the way and the IC will start working. After that, you will see that the next comparator is the undervoltage lockout. This means that if you give the up voltage below a limit, then in this condition, the IC of yours will go into the undervoltage lockout mode, and this undervoltage lockout provides protection to the MOSFET. That is, your IC can operate, but the MOSFET will not get the output. It needs to switch on and off. As soon as your IC goes into undervoltage lockout mode, in this condition, the reference of 5 volts is turned off. And here the voltage reference good logic change noise makes whether the reference voltage is present or not, as soon as it is assured that the reference voltage is not present. In this condition, it turns off the output. And this output is the BWM that goes to the gate of the MOSFET. It turns off. Here you see that the voltage reference is converted to 2.5 volts, and this happens. The buffer is used because its input ingredients are very high and the output impedance is low. Due to this, our reference voltage of 4 volts is not disturbed at all. Here, the 2.5 volts goes to the error amplifier, and there is a voltage feedback in this non-inverting input of the error amplifier. It goes to the inverting input as soon as the voltage feedback of the amplifier goes from 2.5 to 2.51. In this condition, the output of the error amplifier becomes 0, and similarly, the current sense comparator of the amplifier turns off the output. Look. Another smart design has been used here. No matter how much voltage is in the output of the error amplifier, but here a GINA diode has been used to drop the voltage. And this is a 1 volt Zener diode. And the reference voltage of 1 volt goes to the current sense comparator. That is, the current sensing point, which is the 3rd and 5th point. If you give more than 1 world inside it, the IC will turn off the output. If the voltage remains below 1 volt, the IC will continue to function normally. The next point is its RT and CT point. This is the same point from which the frequency of the IC is defined. Here, with the help of a single resistor and a single capacitor, you can define the frequency. Here, the first point of the resistor is connected to the voltage reference of 4 volts, and the second point is it is connected to the RT/CT. The fourth point, similarly, the capacitor has one end connected to the fourth point, and the second end connected to the ground. So here, you can manually adjust the frequency by using a potentiometer instead of the resistor. This will be a very good function. Whenever you look at the data set of this IC, you have to keep in mind that this IC comes in 8-pin and 14-pin packages. We look at its maximum rating. Here, the voltage input means that the supply voltage should be from a low impedance source. A low impedance source means that the capacitor should be able to deliver high current. Here, the voltage should be 30 volts. If the supply voltage is 30 milliamperes, then it is quite good at high voltage frequencies. It charges and discharges high currents quickly. Here, the output energy on the capacitive load is 4 microjoules. The analog input, second and third, that is, the voltage feedback and current comparator, are there, -0.3 to 6.3 volts. If you are using a voltage higher than this, then use a resistor. The current will be limited and the IC will be saved from burning. Here, the output of the error amplifier sinks the current 10 million times. Thank you for watching the video. Subscribe to the channel. I will keep bringing videos like this.